You're listening to China Manufacturing Decoded from the Sofeast Group. Hello, welcome to episode 264 of the podcast. Adrian hosting today, joined by Renaud. Hello, Renaud.
Hey, yeah, how are you?
Good, thanks. How are you doing?
Yeah, great. Yeah, still in India. So, yeah, going around different suppliers here.
Excellent.
I'll, collecting some data. We'll have
Mhm.
something about that to share.
Excellent. Okay. Yeah, excited about that. That's always good to know. This is going out towards the end of March now, 2025. And if we cast our minds back to last week, we were talking about product quality inspections. Well, this week's topic is about manufacturing process controls. And that's definitely connected to product quality, right? And so what I'm looking to do today is to talk about these controls. Manufacturing is, it's a complex process. And as we go through the process, there are certain controls that are set up throughout, which are going to be put in place to help ensure good quality, for example. So to start with, let's just introduce manufacturing process controls and why they matter.
Well, first, not all manufacturing is very complicated, right? If you just have a simple assembly operation where you just put two things to fit each other and that's it,
Mm-hmm.
it can be, it can be simple. Like there's not many ways that it can go wrong.
Sure.
And it's not that difficult to keep it consistent and always have the same output. Now, the thing is, as products get more sophisticated, more difficult to make consistently, let's say, it's really, really important to think of how to keep these manufacturing processes under control. And what does that mean? It means that as long as you feed it with, the right inputs, like the right materials, components, etc., and you do things the right way, the result, the output of the process will be what you need, will be consistently good, right? That's really what you want to do. And you need to go into the analysis of how to make it possible, right? Otherwise, you kind of treat it as a black box. And when you start to treat it as a black box, that's actually very dangerous. It's very dangerous. There's a lot of component suppliers in China. We go there and we tell them, but what you're doing is not great. Like, dude, what should you do better? And they're like, oh, we've been doing that for 20 years. We have a lot of experience, blah, 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 blah. And then we push a bit and we say, well, this specific process here. Oh, we have the master or the, very experienced person right here. He's been doing that for 20 years and he knows this inside out. And like, if he says something is difficult or whatever, like, believe me, it's difficult, but when he's operating it, like, he is world class. He's the best. And then we start to ask a few questions to the guy. And what we see is that he has no understanding of the physical and chemical properties of the process itself, right? And how things work. It's more like he tries something and he sees the result. Now, if you do that a lot, okay, you're gonna learn. But only if you have a mindset of doing experiments, right? What if I change this factor and then I change this other factor, right? If you change one factor at a time, for example, I tweak the temperature up a bit. What's the result? Not too good. Okay, I put it back down. Okay, what about the pressure? Oh, I'm going to put a bit more pressure on this. Oh, it's a bit better. Okay, what about a bit more, a bit more? Okay, if you do that, you can learn, quite a bit. Okay, you can be, how to say, let's say relatively proficient in managing that process and getting relatively good results. No problem. I have no problem with that. But the problem is they treat it as a black box and they do not have this mindset of let's tweak one factor at a time. Let's, keep track of it, document it. when I move this up or this down, this is the result, etc. They don't do that. They they will do different, I don't know, maybe trialing when they see it's not working, but not in a very systematic manner and
Mm.
without documenting it. And I'm sorry, you do that for 20 years. You don't have 20 years of experience, right? As they say, you have 20 times 1 year of experience at most. Right? You
Mm.
don't really learn much. So if you want to do it, how to say, in a good way, if you have a relatively complex process and you want to get good results from it, you get to try to analyze it. You get to try to break it down into the elements that lead to good results, to good output, right? That's the idea. If you do not do that, or you don't really understand it, then you, how to say, yeah, you don't understand your process. And when you don't understand your process, well, when, I don't know, on a day where it's very rainy, particularly humid, or when, I don't know, maybe the equipment is getting a bit worn down and something changes. Okay, you don't even see things coming. You don't even keep an eye on these things, and you're surprised. Oh, the result is not good. Oh, we just made a big batch of 40,000 pieces here. Oh, they are no good. Oh, that's a big problem. I didn't think about that. Right? So you need to use your analytical skills basically to have a theory of how things work. And then based on that, you know what to manage in order to have a good result, right? I can give a few examples because maybe they're
Yeah.
very, very high level, like conceptual. If you make paint brushes, okay, you make paintbrushes, then you need the tool, the glue. You need some glue to hold this brush hair together, right? Okay, otherwise, it's not good, right? They would just fall out and so on, right? Maybe you don't see it right away, but maybe 2 months after, you deliver to your customers and then they keep complaining, hey, your brush is, pretty bad. The hair all goes everywhere. You have a glue problem. Oh, okay. Well, what's wrong with the glue? You need to understand all that there's good glue and poor glue. And then you need to think, okay, if I want to make good brushes, I need good glue. And how to make sure that I get consistently good glue, right? Except, of course, working with a very good supplier. And there's little things that you can do. For example, you can buy a little viscosity measurement instrument. And every time you buy a batch of glue, then you get some of the glue and you measure the viscosity of the glue. you know. And if you see that there's a lot of variation, oh, this batch is quite different from the previous one, and usually it should, from our past measurements, it's usually between this value and this value. And then when it's that value, then we have problems later on. Okay, ooh, I can see a problem right here, right? So you don't necessarily need to understand all the details of whatever the monomers and all the things that go into the glue and why the glue is going to be binding for a longer time and how it reacts to temperature, humidity, etc. You have a very simple way here to measure something that can tell you if the batch of glue is off, right? Very, very simple. A very simple thing here.
Mm.
Now, there's some processes where you can see a lot of these things, right? So we do a lot of plastic injection molding, right? And when you look in these presses, these machines, now nearly all factories have what they call third generation process injection molding machines, right? So you look into it, it's digitized, and you have, I don't know, maybe you have 60 different process parameters, right? The pressure and the temperature and of course the cycle time, the clamping force, etc. But just the pressure and the temperature, you can set it differently at different areas of the press. And anyway, it goes into a lot of complexity. So you have all these things, and then a good manufacturing engineer will understand. Well, first they will read the the material sheet from the material supplier, of course, because different
Hmm.
polymers, different resins call for different, temperature, etc., etc. Okay, and then they will translate that into the right process parameters in the machinery, right? So that's they need to understand that. Otherwise, they will do a lot of trialing, and still the results will not be great, right? Whereas if they have the right theory in mind, they will go much faster to something that's a much better result.
Mm.
And of course, they document it, they save it into the machine, and then they make sure to always run it the proper way. Okay, so it is actually quite important. You cannot do relatively advanced manufacturing without proper manufacturing process controls and
Mm.
expect consistently good results.
Yeah, important. Okay, so that gives a good grounding into what we're talking about today. But and this is kind of conceptual, right? But we've got to try and visualize this for the listeners. So let's move on to talk about the elements of process controls. Now
Mm.
there are four key elements, right?
Yeah, basically there's four key elements. And I'm going to keep the example of plastic injection molding, right?
Hmm.
The first one is the inputs. What do you use? What does the process use? So plastic injection molding obviously is the plastic pellets, is a big one.
Hmm.
So certain things are very important. Well, first, do you always buy the same ones, right? Or do you try, oh, I get a little bit cheaper over there, different kind of, I don't know, PC and ABS mix from different suppliers, a little bit cheaper. I'm going to switch to them. Oh, okay. Then this is going to introduce some variation. Variation is not good, right?
Yeah.
Is it, is it dry? Is it properly packed when you receive it, right? I- Do you need to dry it before you do the injection molding? These are the typical things that are very, very important. Then you're going to use obviously electricity, you know, and ideally it should be a consistent source of electricity, right? If you have power shortages every 30 minutes, that's a problem. Okay. So these are two examples here. Okay. Then another one, obviously you have the inputs, you have the outputs. Okay. This is the result. This is the result. So what are you going to look at? Well, first, you're going to look at the percentage of defective parts that come out of the press, right? Out of the
Mm.
plastic injection molding machine, right? And if you have, I don't know, 1% defective, then it's a 99% yield. Okay. So you need to kind of quantify that. And obviously you need to push that as high as possible. Another one is the waste. So you're going to have all these, the sprue and all these plastic parts that are going to be put aside, right? And that's something with plastic injection molding, something you can really plan for at the design stage, the design of the mold, right? But in some of the processes in my, then you have the number of parts you can make per hour, right? So a shorter cycle time is a very important thing to maximize the capacity of the production process. And if for some reason you have a long cycle time, is really going to impact you, and it might cause production delays, etc., etc. Okay, there's some other things, but I don't want to go too deep here. So you have the
Mm.
inputs, let's say the materials, the utilities, etc., goes into the process, and the process gives you some outputs. What percentage of defects, how many you get per hour, etc., etc. Okay. Then you have the variables. These are the things around the process that that will impact the ability of the manufacturing process to
Hmm.
produce the right kind of output. Okay. So some of them are controlled, some of them are not controlled. So again, for plastic injection molding, some controlled variables typically are the temperature at various parts of the barrel, the nozzle, etc. Okay, you can really set the temperature in different parts. You know, the temperature of the plastic before it's injected, but also you can control the way heat is dissipated into inside the mold. So you can have relatively fine control over that variable. Okay. The pressure also, you have relatively good control over the pressure under which the plastic is kept and is injected and is kept inside the mold with the clamping force and so on. Okay, there's some others, yeah, the cycle time and things like that. You can control all that. You can set it. Okay. And you can repeat it from one batch to another if you have documented it or, your equipment keeps it in memory. Now, there's also some uncontrolled variables. That's the bad news is that there's a lot of things over which you don't really have control that are going to impact the ability of the process to do a good job consistently, right? So some obvious ones are the ambient air will have a different temperature and different humidity pretty much every day of the year, right? So you set things up in, I don't know, in November in South China, and it's relatively dry, and then you do the next job in June when it's hotter and much more humid. Wow, that's gonna have an impact, right? You you need to adjust a bit for it. And some certain processes are much more sensitive to different temperature humidity than plastic injection molding, right? But it still has a bit of an impact. So
Mm.
the I'd say the high end factories that do plastic injection molding, if they really want very consistent results, they will actually use they will really enclose the workshop, and they will keep constant temperature humidity all year long. They will control it at least within a certain band, right? So they will have air conditioning, dehumidifiers, things like that.
Mm.
Okay, which is not cheap. Um, you have the maybe dirt and dust flying around. Okay. So do you want to do that in a relatively clean room? Sometimes when you make parts for medical devices, for example, you may want to do it in a clean room, right? So again, these are examples, putting it in a clean room, keeping temperature, humidity under control, things that are more or less costly, but that allow you to take some of these variables and move them from uncontrolled to more controlled. Okay. So when you work with what I would call a garage kind of operation, a small workshop, just trying to get by, push products out the door, you cannot really invest in anything. It's not really preparing for doing a good job in the long run, let's say, right? And there's a lot of little factories like that.
Mm.
They would just keep a lot of things uncontrolled, right? And whatever, of course, and what can we do? Not our fault, right? The previous one was good, but he left through his mistakes.
Mm.
So these are examples, right? Or the machine, oh yeah, the machine broke down, and then sorry about that, created a long delay. Now we did not do preventive maintenance. I mean, what a weird idea. Why would some why would some people plan for cleaning the machine and
Mm.
replacing some of the key parts and so on in advance before it breaks? Of course not. We just wait until it breaks, right? So
Sure.
that's sort of level zero of manufacturing management. And that's what you need to avoid. If you want to limit the variation in the output.
Mm,
If you don't want many bad surprises, you need to avoid working with what I call level zero, level one kind of suppliers. Very, how to say, they don't try to control their environment. Like they're just a victim of their environment and whatever, right? Oh yeah, the inputs are different. Yeah, oh yeah, right. Why is our supplier, ah, yeah, they screwed us, we didn't see it. Okay, but did you do anything to detect the variation? Oh no, we just receive and we use it right away, you know? Well, we didn't see, I don't know, like, oh, it's refurbished electronic parts on the PCBA. Oh, we didn't see that. Sorry. Right? Did you do
so not
something to check it? Well, no, they're kind of a victim of their suppliers, of their
mm,
staff, of their environment, and so on.
yeah, so no IQC, for example.
Yeah, for example, and maybe they do IQC, but in a very simple way, right?
Mm,
Whereas, okay, as in the example I mentioned before, you buy glue and you want to control the viscosity of the glue. And if you see a clear difference and it doesn't look good, then you send it back to your supplier and you ask them what
mm,
changed since last time and how come you cannot do it consistently, right? There are, there's a lot of ways you can do that to, that's how you keep your operations under control. That's how you keep quality under control, right? Again,
mm,
it's not just, how to say, the temperature, the humidity, the dirt around and things like that. It's training your operators and your inspectors and so on. It's working with the right suppliers. It's preventive maintenance on the equipment just to make sure that it actually functions and gives you the performance and the reliable performance that you
mm,
need, right? When a machine is poorly maintained, it's going to start to act differently. So the purpose of maintenance is to keep it as much as possible in the same state as when it was new, right? So that you can actually count on it to perform as expected,
mm,
right?
mm. Yeah. Yeah, because
So,
you've got your manufacturing process. Hopefully, that's running really consistently. It's running well, right?
mm,
But that's actually it's kind of like the head of the pyramid, isn't it? What about all the stuff underneath that goes
yeah,
into that? How do we ensure the success of that manufacturing process? So, yeah, I can see why those elements really sort of build that.
right, you're right. And yeah, and the setup, right? You get to set it up the right way and whenever you're going to go back to make it a batch of that exact same part or product, you get to set things up the exact same way. So you need to document it. You need to adjust it a bit because, yeah, okay, maybe some of the uncontrolled variables you can see that they're a bit different. So you're going to react to that. You're going to
Mm,
adjust, right? But if you are not aware of the variation in these variables, then again, you're just a victim of your environment and you don't do anything. So it's all about being
right.
proactive, right? So
Mm,
you analyze things, you monitor some of the right indicators with data as much as possible, and then you you try not just to monitor, but to keep some of them within a certain range or to set them so they cannot move anymore, as much as possible.
mm. Okay. So let's move on to talk about a process control plan then, because this is how we're going to
Mm.
implement. This is how we're going to implement this, right? Again, kind of hard to visualize, I suppose, but let's give it a go. So, how do we create such a plan? What's it going to look like? What's it going to include?
Okay, so the control plan, if we apply it to a manufacturing process, it's yeah, it's often called a process control plan, is a relatively standard document in the automotive industry. It's one of the what they call the core tools mentioned by the IATF 16949 standard. And as such, you have some, it's sort of like a working group or something like that. The the automotive associations, let's say this way, right? That kind of prescribe a certain way of doing it. And then a lot of our other industries would say, oh, okay, this is good, and they just use it, you know, in a pretty similar way. But think of it as just a big spreadsheet, okay? And then you have your processes and you break them down into process steps. And then for every process step, you're going to put some information in there, where's the machine or device? Is there some kind of tooling, what is like fixtures, jigs, whatever? Okay. How is this manufacturing process step done, right? What kind of equipment, let's say. Then how actually are people going to check if it's done properly, right? So visually by measurement, blah, 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 right? What kind of data are they going to use to check it up? Okay. So for example, I don't know, you have an oven and you want to check, you have some gauges at different parts inside the oven, and then people are just going to measure temperature with these different gauges, right? It's an example. Okay. Then you give it, usually it's like an A, B, C, how critical is it to quality? Like if it's really critical, then you're going to have to spend more time. You're going to have to give it much more attention. Let's say it this way. And then you're going to have to think of how to make sure it is actually running as expected. What are we looking at and what are the criteria, right? What is there, like, I don't know, minimum value? Is there whatever? If it's something that just is checked visually against a sample, you know, whatever. But what is the criteria, right? And then also, how often is it going to be checked? Is it going to be, I don't know, at the start of every shift, or every 2 hours, or every 100 parts that goes through it, or whatever, right? Or are we going to wait until we have all the output of it per batch, and then we're going to pick some parts at random? How are we going to keep an eye on it?
Mm.
And yeah, just like how is it checked? Then you go back to what are the criteria for acceptance, and then if it's bad, what do we do? Like, oh, do we just stop the process? Do we, I don't know, escalate to a certain level, to whatever, the production supervisor or something? Is it something from the supplier? Okay, then we just send everything back to the supplier, or what, right? What is the reaction plan? That's a very useful kind of format to just to formalize, okay, what are the main steps of the manufacturing process? And then for every one of them, how do we know that it's done properly, right? And some of them are going to be checked mostly by checking their output. So the let's say the quality of the parts that come out of it. And some of them are going to be checked more by looking at the variables. Okay, so I don't know. Yeah, what is the temperature that is running at? Things like that, right?
Mm.
And sometimes more and more, the manufacturing equipment has some sensors, and like it's keeping track of a lot of things. So you just look at the machine and will tell you, I don't know, if you have a SMT process to put components on printed circuit boards, then you can look at it and you can look at the automated inspection machine and so on. And it can tell you, okay, what percentage of the components are placed the right way, and how was the percentage of them that needs to be what they call thrown away and replaced, right? So that's a good thing. But then from time to time, you need to kind of challenge these things and maybe double check it another way, right? If if necessary, just visually and whatever in some other ways. So it's good to double check it.
Okay. And if we look at quality improvement as a concept, right, how are we connecting process controls to quality improvement?
Well, it's a very, very direct link, right? If you have quality issues, it can be traced back to manufacturing process somewhere that is not doing its job, sort of, right? And maybe now the first thing to look at maybe is there a clear standard, and does everybody understand the standard, and what is success basically, right? once you have that in place, then you can go back and look at the manufacturing processes, rank them by criticality, and then the most critical ones, you look at them and you say, okay, is how to say, are the variables and the inputs controlled the right way?
Mm.
If the outputs, for example, there's a lot of defectives coming out of this process, well, obviously, like, we should look very carefully at the inputs and the variables in this manufacturing process to understand. And then, is it a problem of material that's fed into it? Is it a problem of the the method that is followed for this manufacturing process? Is it a problem of the operators? Is it a problem of maybe the measurement process? Is it is there something else that is causing a lot of variation? You analyze it this way, and you break it down, right? And you try to put the finger on a few things that can be improved. And then if you do a good job at that, I mean, the output will be better, right? That's how you improve quality.
Great. Okay. So yeah, we want our manufacturing processes to be consistent. We want them to be repeatable. We want to keep control over those different variables rather than just running the process and just, I don't know, seeing how the dice fall, right? You've mentioned different external factors like humidity and things like that. It's not something that you just shrug and say, oh, well, it's more humid today. Oh, well, we'll just do it anyway. This has got to be taken into account. So I'm following why this is important. Now, this is a quick kind of summary of process controls, right? But we've written a lot of good content about it, which really go into more detail about how to set up a process control plan, for example, and talking in more detail about the controls. So to explore further into the topic, which I totally recommend, do go and check out those links and see how you feel. If you've got questions about process controls, get in touch with us and we'll be happy to help as well. Renaud, thanks for taking us through that. That closes out episode 264. Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review, and share because it will really help others discover us too.